When working in 3ds Max, it doesn't take long to realize just how important it is to be able to read and properly use the X, Y, and Z directions on your transformation gizmo. Reason being is that it's the gizmo that acts like a scene's compass, providing fast and easy input that enables you to keep your bearings straight when moving, scaling, and rotating things around in a scene. You simply grab the appropriate red, green, or blue stick on the gizmo, and away you go. Now, I haven't used this term before, but Max actually refers to the directions that the X, Y, and Z sticks point as something called a coordinate system. And it's working in that coordinate system that allows you to keep track of both what you're doing and the direction that you're doing it in. Max's coordinate system works pretty much the same way as someone who would be driving from one city to another would use a road map in order to most easily find their way. That map providing specific instructions, or better put, specific directions that one would follow in order to get where they're going. On the map, those directions would be the coordinates that one would drive in order to reach their destination. So the world we live in has coordinates, and so does Max. And just like our world is locked down as to the directions things point, meaning north always points north and south always points south and so on, 3ds Max also has a lockdown set of coordinates. They're referred to as world coordinates, the coordinates of its world in other words. You'll sometimes also hear that referred to as a 3D software's world space. And most of the time, moving around in world space, or world coordinates in other words, works just fine. But there are situations when those lockdown world coordinates don't do so well when moving or rotating or scaling something around. In cases like that, you want to transform that object in what are referred to as its local coordinates, kind of its own personal coordinate system. Now, this is very important stuff. Let's take a look at how it works. This is a file named Coordinate Systems, which you can find in the Working Files folder. Let's go ahead and select the object, then activate the Move command. If you want to resize your gizmo, you can do that by using either the plus or minus keys on your keyboard. Notice how the sticks on the gizmo line up to the lines on the grid. Those lines represent the glued down world coordinate directions in our scene, and they don't change even if we orbit our view. As we orbit our scene, you'll notice that the gizmo sticks stay locked down to the lines in the grid. So as long as our object stays in the orientation that it's in, we can continue to use the world coordinates to accurately move, scale, and rotate it in our scene. You'll also find the world coordinate sticks in the lower left-hand corner of the view that can be used for reference. Orbit again and notice how the object's gizmo sticks and the world sticks in the lower left-hand corner stay locked in unison with each other as you spin around the view. Now, when the story changes, and in a big-time way, is when an object in your scene takes on more of a skewed or odd angle. This effectively knocks the object out of being able to use world coordinates and into a situation where it needs to instead rely on its own coordinates, what we were earlier referring to as local coordinates. Let's rotate our object in two different directions, forcing it into an odd angle. Once we've done that, let's go ahead and reactivate the Move command. Notice how the gizmo sticks no longer point in relation to the orientation of the object. They instead, as usual, point in the direction of the grid, the world coordinates in other words. And that now creates a problem if we want to move the object in its own direction. Let's try each, red, green, and blue, and you'll see what I mean. In order to have the ability to move in relation to the object and not in relation to the grid or the world in other words, we need to switch to using the object's local coordinates. Here's how you do that. Up on the toolbar, you'll see a button that says View. Go ahead and click and hold down. These are Max's coordinate systems. From this list, we'll want to choose Local. Now before we do that, let's take one last look at the orientation of our sticks, then we can make the change. Switching over to local coordinates, look how the sticks now line up not with the grid, but to the object itself. And using this new orientation, we can now transform the object in relation to itself. Watch what happens if you grab the red stick and move it in that direction. Try the blue. And if we go in green, it'll shift it in the object's orientation in that direction also. The same situation would hold true if we tried to rotate the object. Notice again how the gizmo rings are aligning to the grid and not to the object itself. So what you're probably noticing is rotate, just like move, has its own coordinate system that's usually locked down to world space. And with our object at an odd angle, it's very difficult, if not impossible, to rotate it correctly. So we instead need to change over to rotating our object using local coordinates. Back to the toolbar, under View, we'll again choose Local. Now watch the rings change their orientation as we make that adjustment. Now we can rotate the object very easily upon itself. Here's red, green, and blue. Same thing happens when trying to scale. Let's activate that using the R shortcut. There again, our gizmo sticks are lining up to the grid, making scaling almost impossible. Try all three directions and you'll see what I mean. Let's instead change over to using local coordinates. Now there is a shortcut key that you can use to make that conversion. This time, instead of going up to the toolbar, I'll simply hold down the Alt key and right-click. In the menu selections on the upper right-hand square, I'll choose Local. Now as I do, watch the sticks reorient themselves. There we go. With local coordinates, I can now very easily, for an example, make my object shorter or longer. Grabbing the green stick, I can make it wider or thinner. And utilizing the blue or Z direction, I can make it thicker or thinner. So hopefully, those examples drive home how important it is to sometimes need to work with an object's local coordinate system instead of the standard world coordinates. Now, there's one more thing I want to show you, and that's when you find yourself in a situation when you want to actually use another object's coordinate directions. Max has a special option for that. This is a file named Down the Ramp. You can find it in the Working Files folder. With the way things are lined up, I think it's pretty obvious what we're intending to do here. We're going to get the ball to roll down the channel of the ramp. Now before we do that, let's first select the ramp. And once we've done that, we'll activate the Scale command using the R shortcut key. Okay, let's say before rolling the ball down the ramp, we wanted to resize the ramp in a couple of different ways. You'll notice the transformation gizmo doesn't appear to be lined up with the ramp, but to the world coordinate system that you can see in the lower left-hand corner. If we wanted to make a few adjustments to the ramp's shape, we couldn't use world coordinates. We'd instead need to change over to local. Let's go ahead and do that. Back up to the toolbar, changing View to Local. With the gizmo sticks now realigned to the ramp, we could now very easily, for an example, widen the ramp's channel. We'll do that by grabbing the red stick. We could lengthen or shorten the ramp by grabbing the Z direction, that being blue. Or we could make the walls of the ramp taller or shorter by manipulating the Y or green direction. Okay, let's go ahead and select the ball and see how it moves. In activating the Move command, you'll again notice the sticks aligning themselves with the world coordinates. So in this mode, being able to properly move the ball is pretty much impossible. Let's instead switch over to the local coordinate system and see if that works any better. This time I'll use the Alt right mouse click shortcut. Now the sticks appear to be going in the direction of the ball, which from this angle almost looks like the direction of the ramp. Let's try red and see what happens. Well, we're going in the correct direction, but watch this. Go ahead and select the ramp real quick. Now once you do that, watch the way the sticks align themselves with the ramp. The blue or Z direction is actually the direction that we want our ball to move in. So in essence, what would be ideal is if we could somehow steal the stick orientation from the ramp and apply it to the ball. And you can do that. Watch this. Let's go back and select the ball. Going back up to the toolbar, we'll open up our coordinate systems, and this time at the bottom of the list, choose Pick. This actually now gives us the opportunity to pick another object in the scene as the coordinate system to use on our rolling ball. With the Pick command active, now click on the ramp. Look at the gizmo sticks as they line up with the ball. Now blue goes directly down the ramp. Go ahead and grab the Z direction and see what happens. Boy, isn't that nice and extremely accurate. Why don't we see if we can't animate this? Down below the timeline, we'll activate Auto key. You can either click the button or simply use the N shortcut command. We'll now take the time slider located over at frame 0 and move it to the right to frame 100. Let's now lock onto the blue stick of our gizmo, moving the ball to the opposite end of the ramp. In order to get the ball to also rotate, we'll have to activate our Rotate command. Well, here again we see our sticks lining up to what appear to be world coordinates. Let's change those over to local coordinates. The rings now line up. We'll grab the blue ring and roll the ball in the appropriate direction. Once you've done that, let's go ahead and play things back. There you go. There's absolutely no way we could have pulled that off if not using the two different coordinate systems that we indeed used. Utilizing the ramp's coordinate system to move the ball, and the ball's local coordinate system in order to rotate. So there's a few things about coordinate systems that you can now apply to your own projects. Situations will definitely be coming up where your transformation gizmo sticks will need to be switched around. So be sure to remember your options and use the coordinate system that works best for the job at hand. I'm going to go ahead and save this out as down the ramp completed if you'd like to go in for a look.